Hello everyone, I'm Despina Solomou, DSP's People and Customer Success Manager. Thank you for attending DSP's breakout session today in NAVIS CONNECT. We strongly believe in teamwork and this presentation is for sure a teamwork. In NAVIS CONNECT, you will have the chance to meet some of DSP members such as Marco, Neil, Daniele, myself, Natalie, Federica, Maesh, Sripad, and Pavitra. We're pleased to announce that we celebrate 35 years. And now a few words about DSP. DSP, that is NAVIS partner since 2007, provides IT solutions and business operation consultancy, taking advantage of its specialized and proven know-how in information technologies applied to the shipping industry, ports, terminals, and intermodal transportation worldwide. So we are in this industry since 1986. DSP now is an international group. Our headquarters are in Lugano, in Switzerland, and we now have an office based in Chennai, India, with the name of DSP Lab, and DSP Talum is based in the Netherlands for our digital twin solution. DSP nowadays counts more than 38 industry experts, and we have done more than 300 projects worldwide. And all this thanks to our customers. Here you may see our products portfolio. First, we have DataView, that is our business intelligence software solution. We have DataBill, our billings application, DataRebox, container maintenance and repair application, Gemini, our digital twin. We also went green with the Green Plus for the energy and environmental monitoring. And last but not least, we have the N4 Peak and the Test N4, tools for N4 installation and testing. Our products portfolio combined with our established professional services to deliver these 4 solution pillars: the analysis and design, the TOS implementation, upgrade support, optimization, automation, and digitalization. So thank you for listening, and I will now pass the floor to Marco Femmer, DSP CEO, that he will now present the first case study of our presentation. Thank you.
Thank you, Despina, for your introduction. We would like to move on now with our business case, the first business case we will present to you today. It is about the DSP Valencia Terminal in Spain, where we have started the deployment of our digital solution for container terminals, the digital twin, with the aim to forecast operational data and optimize resource allocation. So first of all, what do we mean by digital twin? So at the end, we have a real world where we see what really things happens, where people is there, equipment is there, and on the other side, we have a digital model where a digital representation of reality is in place. And we can get all those data from different tools and systems, a different variety of technology. And we would like to use our Gemini, which is our digital twin, to be able to forecast data, to simulate what is happening, to emulate our TOS, and visualize whatever is happening. So it's multi-layer, different modules available. This is the idea, and to tailor the digital twin on your needs, because of course you could achieve such a variety and magnitude of information, and we have to really target to what is needful for the specific case. Now, for example, focusing on here on on this business case, the aim was to identify the best number of resources to deploy on each shift, which is quite common at the end. If we start from the model, very easy, of the container terminal, it's like a box where we have a container entering on the vessel side and container entering land side by rail or by truck. All these volumes and units coming to the terminal are somehow modeled even by other digital twin. Here we see the vessels moving through their GPS systems and other interesting tools in the Mediterranean Sea. But in the same way, we may even track where trucks actually are, like Google Maps or other tools of which we are all very familiar, or cameras or whatever. So it's the Internet of Things. Now, when we start collecting all this data, having information, the aim is being able to understand what's going to happen thanks to this information and build what-if scenario. For example, here we can change the crane plan, say one crane is not available on that shift, or can work only less hours, and all this will reflect in the whole terminal. So basically, since we are here at NAVIS Connect and we are all familiar with N4 terminology, we could say this is like a key commander for the future and for the whole terminal. When you change the plan of one key crane, this change will reflect in the whole terminal to all the other vessel and the workload in the yard. So changing, for example, here, the number of RTGs available will change, of course, the scenario, including the expected time of departure of the vessel. The starting point is the berth plan and the long-term schedule, where we can define in which, when, and in which order all our vessels calling the terminal will arrive. Whatever is not available on the long-term schedule and cannot be populated directly from the TOS, that is connected live to Gemini, it's calculated based on mathematical models of historical moves and statistics. This includes even the crane split that usually was applied for vessel, and the same way loading and discharging moves before we receive any BAPI or any other information. In this way, we could have a very detailed idea of when and how container will arrive. Then for each vessel, we have built a curve that represents when container will arrive at the gate. So for the export side, we know that there is a start of acceptance of container, there's a closing date, some late arrival, and then at the end the start of operations. But this is an asymmetric Gaussian curve in most of the cases, so most of the container will arrive close to the start of operation. The magnitude, it's up to the number of units usually moved by that service. So if we build this curve for each vessel calling the terminal, we will have something like that, let's say. So each vessel will have its own curve, and for each shift or even by hour, we can have a sort of a forecast of model telling how many units are expected to arrive in total at the gate. In the same way, we build a model for import delivery that is based on the container currently in the yard, the planned discharge move, forecast discharge, and delivery model. Delivery model that is based on local special agreement that the terminal may have, for example, on their storage contractual terms, cargo special typology, if there is any bill of lading, big amounts that will be collected in a certain order very altogether, or the custom procedures in place at that site, or regional logistic in case the terminal is nearby warehouses or distribution center, and truck drivers and trucking company would like intent to, for example, perform 2 or 3 eventually trips on a single day. All these elements, so the export curve and the import curve, shall be then coped and harmonized with the operational opening time of the gate. So we have to take in account on weekends or bank holidays or other special situations so that we can really model whatever is happening in the reality. So having all this information together, I think really bring great value. The result, it's displayed on a dashboard and with indicators, so numbers at the end that will help us take a decision and will help us improve, for example, in this case, the gate process, by providing a decision support for a good truck appointment strategy. So really giving an idea how we would like to model this appointment strategy and the way we connect and the way we communicate to the trucking company and the local community, port community. We can deliver, thanks to this model, traffic forecast and waiting times at the terminal to truck drivers directly on their smartphone, which is of course very helpful. They can even increase the quality of their life. Overall, this is expected to reduce delivery times, prevent traffic congestion, not only in the terminal, but even in the local area in town, especially if the terminal is really connected to a highway or to viability of the local community. Of course, we will get an optimization of terminal resources. For example, how many really RTGs should be deployed on that shift, how many crane lanes should be opened up. And last but not least, it will be a decision support for our yard planning strategist, understanding how many imports bays will be needed, how many export bays in order to prepare the yard to accommodate the different traffic flows. Then I have to say it's it's really a must to consider this. If we reduce the waiting time of the trucks and the way they move around the city, the way they wait at the terminal, and we expedite in general the speed of their visits, at the end we will get a reduction of the CO2 footprint, which is an overall well-recognized value nowadays. So at the end, I would like to show you our dashboard, but you see it's quite similar to any dashboard you can have. So it's telling you how many moves are expected, how many vessels along quayside. But the main difference here is that we have these buttons on top left telling next shift and previous shift. So we have a dashboard of the future, let's say. And this is very interesting, where we see the value, because it will help us in taking decisions, taking better decisions, changing some of our strategies. So thank you very much for your attention on this. Now I hand over the speech to Neil and to the next business case. Thank you very much.
Thank you, Marco, for that interesting information about Gemini. My name is Neil Escott. I'm the Senior Manager for Business Services at DSP, and I'd like this opportunity to let you know about a project we did with Europhos earlier this year to help them and support them with their upgrade from 2.6 to 3.6 and help synchronize data for doing a dry run test with live equipment. So Europhos is a straddle carrier terminal based in the south of France on the Mediterranean coast. And currently they have 600,000 TEUs as a throughput. So we started the project in December. DSP was assigned to a system in preparation for the infrastructure, helped them with clarification on 3.6 functionality, and helped them with issues that came up during their initial testing. The plan was to do a live data run with straddle carriers, key cranes, gate equipment at the end of their main testing. And we were asked to help them with a gate operation process. So we did one shift, a barge operation, which was a complete barge, and then a vessel operation, all on separate days. The dry runs commenced in April this year, and we completed everything by May. So the gap was mainly because they had to pick appropriate vessels and barges to make sure that they had the right team and the best people to support them. During the actual testing with the dry runs, we came up with some additional issues that were not identified during the end-to-end testing and the unit testing. So the benefits were that we actually found faults, mainly in the vessel operations, that were not identified in the lab. So the results were that NAVIS were able to fix these issues, and they were all complete in time for their go live. So what I'd like to do is pass you over to Pavitra now. She's one of our senior developers, and she looked after the technical side of transferring the data. Thank you, Pavitra.
Thank you, Neil. I'm Pavitra. I'm a senior developer with DSP Lab based Chennai. So now I'll explain you the technical approach which we followed for the dry run with Europhos. So in Europhos, we used the SNX feature of N4, where we developed a Groovy job and executed in 3.6 to import the units of the 3.6 environment, which has been updated during the live, and it has been pushed through again a Groovy job as an SNX import in the 2.6 environment. So the SNX job will be automated. So we followed the similar approach for the vessel and barge operations. Along with the units, here we considered the line load list and the discharge list for Europhos, where we had a Groovy job to export and import the same in the 2.6 environment. So how did we tested this? Whether the data is being synchronized between the 3.6 and the 2.6 environment. So we validated by verifying the imported unit in the 2.6, and we verified the line load list and the discharge list. Along with this, we verified the event history of the respective units and the availability of the unit in the appropriate position in the XPS client. So we did a similar approach, but with a little condition added to it for the gate operation, where the units were considered only when the gate transaction is completed. So we considered only the units for export and import when the gate transaction gets completed. Here, we considered the chargeable unit events and the chargeable appointment events for Europhos. Along with that, we also considered the synchronization of orders, EDO, ERO, and booking, along with the tally in, tally out of the orders. So in the gate, we validated the chargeable unit events and the appointment events, along with the tally in and tally out details as well. So similarly, we already usually verify the unit event history and the availability of unit in the 2.6 application. So these are the manual verification between the unit availability in 3.6 and 2.6. So we generated few reports for Europhos, where we can generate the report for a specific period of time for critical attributes of units and other entities which are required through a Groovy job, where we can reconcile the data between the 3.6 and the 2.6 environment. So this is a unit report sample which we have displayed. Along with the units, we have CUE, CAE order, and for respective order, we have the order items, line load list, and the line discharge list. We do generate reports for the vessel visit if there is any change in the vessel visit, and those details will also be updated in the respective reports. So apart from this, the deliverables which we gave out for Europhos is the Groovy source code with the proper documentation, user guide for the deployment, and the use cases which we tested and delivered to the client. So with these details, with the similar technical approach, it was very easy for Europhos to successfully complete the dry run. So if you have any questions on this, please do write to us. Thank you. Anil, it's over to you.
Okay, thank you, Pravitha. Yes, so it was something that the customer had asked us to do, and it did take a couple of months. It wasn't as simple as just switching something on, and it was something completely new for us and for them as well. But the dry run proved successfully that there were issues that were missed during the unit testing and the end-to-end testing, and it helped a very successful go live, which they completed later in the summer. So as Pravitha said, if you have any questions, please put them in the chat and we'll answer them as they come through. And thank you very much for listening to us today, and we look forward to speaking with you soon. Thank you.
Thank you.